Hello students, today I am going to discuss with you one theorem on reduction of coplanar forces. So it will be new to you because you haven't come across this thing, coplanar forces, how to reduce it. But before that, let me just recall or let me just define some definition from unit 1 we are needed for this thing, for the theorem. So this couple moment of a couple, I'm going to define here what is meant by these two definitions. Two equal and unlike parallel forces whose line of action are not the same are said to constitute a couple. What does it mean? Suppose here you have two equal forces P and Q, P, okay, they are equal forces, but unlike mean one is acting upward and the other is downward, and whose line of action are not the same, means one is acting upward, the other is two equal forces. They are parallel forces, as you can see. Moreover, they are equal, but their line of action are not the same, means one is acting upward, the other is downward. These two forces are said to constitute a couple. Whereas in this case, forces P and P, they are parallel forces and they are equal, but they does not constitute or does not form a couple. Why? Because they are the line of action is in the same direction. That is, P and P, they are acting in the same direction. So thus we say that two equal and unlike parallel forces whose line of action, this is the example of a couple whose line of action are not the same but they are equal and unlike parallel forces. So these two forces constitute a couple. Now what is meant by a moment of a couple? Or I can give you an example of a couple is that by a force applied by a hand, okay, to the handle of a door latch in opening it. While you open a door, okay, you apply to the handle of a door latch while opening it. So that is called a couple. That force you apply there is called a couple. And the whole effect of this couple on a rigid body is to produce rotation without imparting to it any point a motion of translation. So this shows that the whole couple is to produce rotation without imparting any motion of translation. And moreover, this couple is either positive or the moment. Okay, let me first define what is the moment of a couple. The moment of a couple is the product of either. So this, as you can see in figure 1, this force P and P, they constitute a couple, and the distance between them is denoted by small p. So what is meant by moment of a couple? It is the product of either of this force, either this into its perpendicular distance between the line of action, that is the distance between these two forces which form a couple is denoted by small p. So the product of this force, either of this force, capital P, into its perpendicular distance is called the moment of a couple. So the moment of a couple is a product of either of the force forming the couple and the perpendicular distance between their line of action. And this moment of a couple is either positive or negative. It depends on as the couple rotate clockwise, anti-clockwise. If it is rotating anti-clockwise, like in this case, okay, if it is rotating in this forces P and P which forms a couple, if they rotate in this anti-clockwise direction, so the moment of the couple, that is P into small p, is positive. But if it is rotating in this direction, in the clockwise direction, it is said to be negative. Okay, so moment of a couple is positive or negative as the couple tends to rotate the body in anti-clockwise or clockwise direction. Now we come to the main theorem on this reduction of coplanar forces, that is unit 2. Okay, so what does it state? Any system of coplanar forces acting on a rigid body can be reduced to either a single force or a single couple unless it is in equilibrium. Equilibrium means a rigid body is said to be in equilibrium if it is either at rest or it is moving with a uniform speed. So any system of coplanar forces acting on a rigid body, you can ultimately reduce it to either a single force or a single couple unless it is in equilibrium. So you have this, this is a rigid body, suppose here it's a rigid body, and a system of coplanar forces P, Q, R, S, T and so on. They are all system of coplanar forces acting on this rigid body. What we have to prove is that this whole forces, this system of coplanar forces acting on this rigid body, these forces P, Q, R, S and so on can be reduced to a single force or a single couple. By couple we means that the product, if two equal and unlike parallel forces are said to constitute a couple. So this whole system you can either reduce it to a single force or a single couple. So how we prove it? So you have P, Q, R, S, T. P, Q, R, S, T and so on. They are system of coplanar forces acting on a rigid body. So first of all, let us consider any three of these forces, that is P, Q and R. So as you can see here, forces P is acting upward and this is in this direction. So if you extend this and this one, so you can see that P and Q they can meet at a point. So therefore, by parallelogram of forces, which is in unit 1, these forces combine, forces P and Q can be combined to a single force. So among these three forces, with P and Q, you can meeting at a point, with forces P and Q meeting at a point, you can combine these two forces into a single resultant forces by the method of parallelogram of forces, which will be discussed in unit 1. This is possible if these two forces meet at a point, that is forces P and Q meet at a point. Otherwise, if they don't meet at a point, and means that if they are parallel, if forces P and Q, suppose it is in this position, suppose now P and Q they don't meet at a point, it means that if they are parallel, like or unlike, like parallel forces means they are acting in the same direction, unlike parallel forces means one is acting upward and the other is acting downward. So if they are unlike parallel forces, P and Q they are unlike parallel forces, again these two forces P and Q can be combined into a single resultant force by the method of combining of parallel forces. Or if they are like means they are acting in the same direction, parallel, so these two forces again can be combined into a single resultant force, excepting the case when they form a couple, because if they form a couple, in that case P and Q must be it is acting P and Q, they excepting the case when they form a couple, that is P and Q they are unlike equal and unlike parallel forces. So now in case P and Q, okay, in case P and Q they form a couple, means one is in this direction and the other is in this direction, so they are unlike parallel forces. P and Q form a couple means P is equal to Q. The first condition to form a couple is that forces P and Q must be equal and they are unlike parallel forces. So we can combine this force, this P and Q which forms a couple, we can combine it into a single force unless P forms a couple with R also, because we are considering P, Q, R. Okay, so if P and Q form a couple, we can combine it into a single force unless P also forms a couple with R. So in that case, R is also in this case, P here is equal to R. So in that case, these two forces here, they are like parallel forces. So again, by the method of combining of parallel forces, combining parallelogram of forces, these two forces can be combined into a single resultant force. So therefore, these two forces can be combined into a single forces, and in either of the case, in any of the cases we have discussed, we can see that these three forces can be always reduced to two forces. These three forces can be reduced to two forces in any of the cases that we have discussed. So with these two forces that you have obtained from by reducing these three forces, then you consider another force S. With the forces you obtain from here, the two forces you obtain from these three forces which reduce to two forces, you consider another force S, as you have seen in the diagram. With these forces, now what we need to do is that consider the same method. Either of the forces, two of the forces meet at a point, you can combine it into a single force, resultant force, by the method of parallelogram of forces, or by the, if they do not meet at a point, then they must be parallel, light or unlight. Then again you can reduce those two forces, just like in this case, into a single resultant force. So therefore, as you can see that these three forces, two from you obtain from here, and with this force S, you can always reduce it to two forces. Proceeding in this way, all the forces of the system P, Q, R, S, T, and so on can be reduced to a single can be reduced to two forces or a couple. If thus two forces, if they are equal, once you reduce all those system of forces to two forces, so if they are equal and opposite, acting along the same line, so if those two forces you obtain by reducing those system of forces, they are equal, P and P, but they are acting along the same line, so they are said to constitute, so they will produce equilibrium. Otherwise, if they are equal, if the forces P you obtain, forces say P prime, and forces Q, they are equal but act unlike parallel forces, so they will form a couple. And in case if they do not form a couple, so therefore those forces you obtain, say if they do not form a couple, so P prime and Q prime are the two forces if which does not form a couple, or which are neither equal or opposite acting along the same line, you can combine them into a single force by the method of parallelogram of forces. So in any of the cases we have discussed, you can reduce all these forces into a single force or a single couple unless it is in equilibrium. Unless it is in equilibrium means unless all those system of coplanar forces you have reduced to two forces are equal and opposite acting along the same line, means they are in equilibrium, you can always produce those two forces. You can always reduce it to a couple or a single force, as in this case, because whatever forces you have here, this P, Q, R, you can always reduce it to two forces. Those two forces, after reducing the system of coplanar forces acting here to two forces, those two forces can be either equal and opposite acting along the same line, so which means they will produce equilibrium. If not, they will form a couple. If they are equal and unlike parallel forces, they will form a couple. If not, then they will reduce to a single resultant force by the method of parallelogram of forces. I hope it is clear to you what is meant by this. Any system of coplanar forces for PQR are the system of coplanar forces can be reduced to a single force or a single couple unless it is in equilibrium.